this section, we're going to look at graphing the other trig functions, so not just sine and cosine, and then answering a few characteristics of those graphs. So those characteristics are going to be things like where are the asymptotes, if it has any, what's its domain and range, is it an even or an odd function, and based on that, what type of symmetry does it have, what is the period of the graph, and is the graph continuous or discontinuous. So part of what we will need to look at is what are the other four trig functions. So what does tangent and cotangent look like, and what does secant and cosecant look like, and then we can talk about those different properties. Alright, so we're going to start off with sine and cosine because we're familiar with both of those now. So you still need to know sine looks like this, and if it helps to plug in some values into a table to do that, then please do. And cosine looks like that. Okay, same thing. Plug in values into the unit circle, make a table to help you make that graph if needed. But since we've been working with these two a little bit longer, hopefully you don't need to do that. Okay, so I look at these two graphs, and neither one of these has any asymptotes. There's no sudden breaks in the graph. So sine and cosine do not have any asymptotes. Domain, remember domain is a way to describe what x values you can plug in. And since this actually goes on forever to the left, forever to the right, forever to the left, forever to the right, it's hitting all these x values, so we can plug in everything from negative infinity to positive infinity. We can plug in all real numbers. Now also remember, when you do this in domain, always put the smaller number on the left and the bigger number on the right. Okay, range is a way to describe the y values that the graph hits. So the parent functions look like they go as low as -1 and as much as +1. So small number on the left, big number on the right. Same thing over here. Oh, my graph doesn't really look like it, but it's supposed to look like that. And now it actually does hit a y value of -1, and so does this one. So we need a bracket to include it, and it hits a y value of +1, so we need a bracket to include that too. So domain, it's a way to describe the x values that the graph hits. Range is a way to describe the y values that the graph hits. Alright, so earlier this year I asked you to memorize which of these trig functions are even and odd, and the only even ones were cosine and its reciprocal. The other four are odd. Now how that is important to us is the type of symmetry. Even functions are always symmetric to the y-axis, which means you could flip the graph over the y-axis and keep the same graph. So look up here at cosine, imagine flipping that graph over the y-axis, and you can see that the graph stays the same. So that's a characteristic of being an even function. Whereas an odd function is symmetric to the origin, which means that it has 180-degree rotational symmetry. So if you took this sine graph and you turned it upside down, it's still going to look the same. So if you rotated it 180 degrees, it stays the same. We call that symmetric to the origin. Alright, so we can look at these graphs and we can measure the period. You need 2 pi of space for each of these to see the full rotation. And these are the only two trig graphs that are continuous. And what it means to be continuous is that you've got a nice smooth graph going on. There's no sudden breaks in the graphs. There's no asymptotes. There's no jumping around. It just continues from one point to the next, nice and smooth. Alright, so let's now take these same topics and let's look at tangent. So we're going to answer the same questions about tangent, which isn't too hard to do if we know what the tangent graph looks like. So, like the sine and cosine graph, it kind of helps if you know what tangent looks like. It might not be a bad idea to memorize it, but it also doesn't hurt to plug in a few values. So let's say I plugged in 0. The tangent, remember tangent is sine over cosine. So if this was 0, the sine of 0 is 0, and the cosine of 0 is 1, and 0 divided by anything is 0. So plugging in 0, I get 0. The tangent of 0 is 0. Alright, and then maybe you plug in something like pi. So at pi, tangent is 0 again, and cosine is -1, but 0 divided by anything is 0. So there's another point. Okay, maybe I'll plug in something in the middle here, like pi over 2. And at pi over 2, sine and cosine are equal. They're both square root of 2 over 2. So anything divided by itself gives me 1. And how about we plug in, how about negative pi over 2? So at negative pi over 2, that's not right, hold on, backtrack. At pi over 2, I'm sorry, I was thinking pi over 4 there. So let me go ahead and just change that one. At pi over 4, sine and cosine are equal, so that would be 1. So here would be pi over 4. All right. But at pi over 2, cosine is 0, so this is undefined. You cannot plug pi over 2 in because cosine is 0 there, and you get division by 0. So when you try to divide by 0, that's when you get either a hole or an asymptote. Now these graphs don't have holes, they just have asymptotes. So we get that. So I can plug in more points. More points is always better. What if I plugged in like negative pi over 4? Well, at negative pi over 4, sine and cosine are equal, except one of them's negative. And maybe I try negative pi over 2. At negative pi over 2, sine is -1, but cosine is 0, and we can't divide by 0, so this is undefined. So you can spend all day plugging in points, but I plugged in some of the more important points so that we can kind of see what the graph's starting to look like. And so if we plugged in more points, you're going to see these are kind of connected with a little bit of curvature to them. And then as we get close to this value that's undefined, that's going to go to infinity. And as we get to this value that's undefined, it's going to keep going in the same direction, so that's going to go to negative infinity. So that is one full period that you see there. And so now we could copy and paste. To complete the graph. Now again, it's much quicker if you just memorize what tangent is, but plugging in a few values into the unit circle to confirm those points certainly isn't going to hurt us. Alright, so now we can look at the asymptotes. This one has a bunch of asymptotes. Okay, and so there's actually infinitely many, because of course this graph goes forever to the left and forever to the right. So, but what I could say is the first one is when x is pi over 2. That would be right here. And then I guess I could say there's another one at 3 pi over 2. And then there's another one over here at negative pi over 2. But again, you can't list them all out. So what we've got to do instead is come up with a formula. So I like to start off with the first one, which is pi over 2, and then say plus all the other ones are pi units spaced out. That distance is pi, pi, jump another pi. So plus any integer multiples of pi. So n is an integer. N is an element of the integers. Okay, and then that's like a formula that gives us all of the possible asymptotes. Okay, now that's important for domain, because domain is what x values can I plug in, and I can basically plug in anything I want to, except I can't plug in x values, or x values can't be pi over 2 because it's undefined there, and then any pi multiple of that. So very similar answers, but asymptotes are asking where are the asymptotes, so that's when x equals these, and domain's asking what can you plug in, and you can plug in anything except those, so don't include those. Alright, range is supposed to describe the y values that the graph hits, and so looking at the graph, looks like it hits all the y values. Tangent is an odd function, which means it is symmetric to the origin. So if you have this printed out, flip your tangent graph upside down and see that it stays the same. But odd graphs always are symmetric to the origin. That's a characteristic of being an odd function. When I look at this guy's period from here to here, about this much space, that is only pi. We only need to see pi amount of space to see its full pattern. So that's different than sine and cosine, but this one only needs pi. And this one has all kinds of breaks in the graph. All these different asymptotes make this a discontinuous function. To be continuous, it's got to have no breaks in the graph like that. Alright, let's do the same thing with cotangent. So it might be helpful to think of cotangent as cosine over sine. So again, I kind of know what cotangent looks like. I've got it memorized, so I could graph it very quickly. But let's just say you completely forget, or a good way to check some of those points. So let's plug in a few. At 0, I would get 1 over 0, so that is undefined. So this one's going to have asymptotes, or an asymptote right there at 0. You could try to plug in pi, and this would be -1 over 0, so that's undefined. Again, I'm just picking points here. There's nothing wrong with any other points. Pi over 2. Pi over 2, cosine is 0, sine is 1, 0 divided by anything is 0. Okay, maybe pi over 4. At pi over 4, sine and cosine are equal, so you divide things that are the same, you get 1. And I think maybe one more good point on this one would be, extend my table here, 3 pi over 4. At 3 pi over 4, sine and cosine are the same except one is negative. So you can start to see if you're really comfortable with the unit circle, it doesn't take as long to think about those points. But so for this section, we won't have you manipulate these in any way. No amplitude changes, no phase shift changes, no vertical stretches, none of that kind of stuff. So you can just straight up memorize the graph. Well, there's one period. Let's go ahead and complete our graph by continuing the pattern. So that's what it would look like here, and here, and here. Feel free to plug in those points to confirm that. So it's got kind of the same like snaky pattern to it that tangent does, but its asymptotes are in a different spot and the direction of the graph is in a different spot. So if you have any doubt at all that you're memorizing that correctly, just plug in a few points into the unit circle, like I did, to be sure that you're going the right direction. Okay, so its characteristics, its asymptotes, it's got infinitely many asymptotes like tangent. So I would say the first one is at 0, and then all the others are pi units spaced out. So plus integer multiples of pi, and n is just our symbol for integer. Okay, but of course adding 0 doesn't really do anything, so we just say n pi. So at 0 pi, 1 pi, 2 pi, -1 pi, -2 pi, -3 pi, etc. Okay, and then the correlation between that and domain. The domain is what x values can I plug in, and I can plug in any x value I want to, as long as x is not where an asymptote is. So those are very, notice how these are similar for both questions, both trig functions. All right, the range, it hits all the y values. everything from negative infinity to positive infinity. Cotangent is an odd function, which means it's supposed to be symmetric to the origin. So you can rotate it 180 degrees and the graph looks the same. Looking at our graph here, we can measure how much space you need to see a full pattern, and that would be pi. And it's got all kinds of breaks in it, so this is discontinuous. Okay, so notice all of this is not too hard to answer as long as we can get the graph correct. So this is most important, and then those are second most important. Got to get the graph right though. All right, the only other two trig functions are secant and cosecant. So let's do secant. Secant is 1 over cosine. So same thing, you forget what it looks like, feel free to just plug in some points into the unit circle. At 0, cosine is 1, and 1 over 1 is 1. At pi over 2, cosine is 0. So, cosine is 0, so that would be undefined because you can't divide by 0. Maybe you could try pi over 4, and at pi over 4, you would get 1 over the square root of 2 over 2, which as a decimal type it in my calculator carefully. It's about 1.4. So I wouldn't normally round it like that, but in this case I want to see where that's going. We could do negative pi over 2 and cosine 0 there too, so we can't divide by 0. And maybe one more, and then I'll show you what the pattern looks like. If I tried to plug in pi, the cosine of pi is -1, so 1 over -1 is going to be -1. And again, more points, always better, but if you know the general shape of the graph, then this is going to be enough. So this is a bunch of parabolas where one parabola opens up, and then the next parabola is going to open down. Next one opens up, next one opens down, next one would open up. So it's alternating parabolas opening up and opening down. But if you don't remember where it starts, or if it opens up or opens down, again, just plug in a few points on the unit circle. You don't have to plug in the same points that I did, just enough to get an idea of what the graph looks like. Okay, so my asymptotes, there's infinitely many asymptotes, so it looks like the first one is at pi over 2, and then all the other ones are pi units away, so plus any integer multiple of pi. The domain is asking me what x values can I plug in, and I can plug in anything I want as long as x is not at an asymptote. All the other x values give me points on the graph. The range is asking me to describe the y values. So the smallest y value is -infinity. Infinity and negative infinity always have parentheses because you can't really reach them. And then that goes up to -1, which it actually includes. And then it skips all of these y values, but then it includes from 1 that it actually hits forever up, which would be infinity. Okay, so these have to have brackets because it actually includes those. Infinity and negative infinity never have brackets because you can't reach them. All right, secant is the other even function, so this graph would be symmetric to the y-axis. So notice if you flip the graph over the y-axis, you would keep the same graph. And to look at the period, if I started measuring here, if I only went to pi, I would only get a parabola up. I have to go to 2 pi to see the full pattern. Parabola up, parabola down. And this has all kinds of breaks in it, so this is discontinuous. The only continuous graphs for trig is sine and cosine. The others all have breaks in them. Okay, let's do the same thing for cosecant, which is 1 over sine. So 1 over sine, if I plugged in 0, at 0 you would get undefined, because you can't divide by 0. If you plugged in pi over 2, you get 1 over 1. If you plugged in pi, cosine is, or sine is 0 again, so can't divide by 0. If I plugged in pi over 4, let's see, that would be 1 over the square root of 2 over 2, so that would be like this guy over here, about 1.4. Okay, and so now that's going to be enough for me because again I know the shape of it and it's actually very similar to the secant graph. It also has parabola up followed by parabola down, followed by parabola up. And again, there's nothing wrong with plugging in more points to see that, but it's also kind of unnecessary as long as you know what the shape of the graph looks like. So this time our asymptotes start at 0, and then the others are integer multiples of pi away. So n is an element of the integers. This fancy e means that. All right, domain, well, adding 0 doesn't do anything, so we don't list that. Domain is what x values can you plug in. Well, you can plug in anything as long as x is not one of those asymptotes. Range, well, it's hitting all the same y values that secant was hitting. So it hits these y values, and then it jumps up, and then it hits those y values. Cosecant is an odd function, which means it is symmetric to the origin. So flip that graph upside down and see that it still looks the same. The period, if I started measuring here to here, I only have a parabola up, but if I went from here to here, I could see the full pattern, parabola up followed by parabola down. And that distance is 2 pi. And this got a bunch of breaks in it, so this is discontinuous. All right, so for your studies, what you should probably know is secant and cosecant are called cofunction graphs. So notice how similar their graphs look like. Now where their parabolas start opening up and start opening down are in different places, but as long as you know the general shape, plugging in a couple of unit circle points should help you figure out which one is which. Likewise, tangent and cotangent had very similar graphs. So knowing that they look alike helps, and plugging in a few unit circle graph points helps you make sure that you know which one is which. And then, if you can get those 4 graphs correctly, then you can answer the questions, asymptotes, domain range, odd and symmetry, period, and continuous or discontinuous, because you've got this to look up, and then you just need to understand what these things are asking. So this is all of section 4.6. So there's nothing else from the book. There's no book practice. There's no like extension of these questions. There's no stretching these graphs or shifting these graphs or applications of these graphs. We literally just want you to know what the 6 trig functions look like, 6 parent functions, and be able to answer these question types for each one.